Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we are going to conduct another video tutorial in which we will be covering about Intel 8086 or 8088 internal architecture. Okay, since this internal architecture is equally applicable to 8086 and as well as 8088, right? So 8086 and 8088 are two well-known models of uh, Intel, right? Intel microprocessors, right? So they are this architecture is valid for both of these microprocessors, right? So first of all, we need to know what is architecture, right? What is internal architecture, right? So the word architecture means uh, it provides the description about circuit building blocks, right? I mean, whatever the circuits which are used internally, right? And that implement the software and hardware architectures, right? I mean, how these different blocks which are present inside this 8086 or 8088 microprocessors, they are connected software wise and hardware wise, right? So that is called internal architecture, right? So we are just it is a layout of overall circuitry and their software and hardware connections, right? Okay, before we proceed and understand how this architecture works, you need to know that this architecture can be divided into two different parts, right? One is called the left side unit, right? This unit, let me highlight it for you. This specific unit is basically execution unit. You can see the name in the bottom, right? And this unit, right, this right side portion is bus interface unit, right? Then there are so many other things, but one thing which is very important to know that they independently are processors, right? Means execution unit itself is a processor and bus interface unit itself is a processor. That means you can say that there are two processors working on in single chip, right? Of 8086 or 8088 microprocessor, right? So that is why one can also say that they are implementing one important technique which is known as parallel processing, and how this parallel processing is working or is in progress in this unit I will explain you later on. But this 8086 or 8088 architecture follow the principle of parallel processing, because there are two parallel units or two parallel processors. One is bus interface unit, another is execution unit, working on two different things at a time or simultaneously, right? So let's proceed our lecture further. Okay, first of all, let's discuss what is the main job of execution unit and what is the main job of bus interface unit. So the job of bus interface unit, like its name, it is interfacing unit, right? It connects you with the outer world, uh, right? And what outer world? Outer world means input output devices, memories which are connected to microprocessor, right? Those are basically outer world. So bus interface unit connects those outer worlds or outer units with execution unit. That is why this bus interface unit is known as interface unit or bus interface unit. It involves number of buses which are connected to memory, which are connected to uh, input output sections, right? And they are also connected internally with execution unit. So bus interface unit is providing job of interfacing the external circuitry with the execution unit, right? And that is why it is known as bus interface unit. Now let's come back to the execution unit. Execution unit, as its name suggests, whatever the instructions are coming, they are being executed or they are being decoded in this section. This is called execution unit, right? So whatever the instruction coming from outer world or from outer sections through bus interface unit's job is to bring them inside microcontroller, and the job of execution unit is to execute those instructions, to understand what needs to be done against those specific instructions. So that is why there are two processing units. One is working on interconnections or interfacing, and other is working on execution unit. That is why I told you that it is a parallel processing architecture. Okay, right? And in this parallel processing architecture, one unit, bus interface unit, is fetching the information or fetching the instruction, and other unit is executing it. That means two processes has become totally independent and they can be run simultaneously. That is why it is known as it is basically more efficient and higher performance translator, right, for 8086 and 8088 microprocessors. Okay, now let's focus on bus interface unit, right? In this unit, we see number of sections. For example, this is our instruction queue, right? This is our instruction queue, right? These are different segment registers which are very important, and we will be considering them in our overall course frequently. And there is an IP register which is called instruction pointer, right? And this is a very important job of bus interface unit: address generation, right? Address generation, right? So I actually enlisted some of the key building blocks, right? It involves instruction pointer, right? I hope you can see that. Ip is instruction pointer. Then there are various segment register. What are segment register? We will be seeing them in detail in coming classes, but right now we are just enlisting them, right? And then there is instruction queue in which it's like a queue. If one instruction is under progress or under execution, so instructions are being stored here. So 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte. So instruction queue is of 6 byte, right? In 8086 architecture, instruction queue is of 6 byte. And there is a first difference we need to know between the architecture of 8086 and 8088. In 8088, this instruction queue is of 4 byte, right? So let me write it so that you remember it. It is 4 byte in 8088, right? If I'm talking about 8088, so instruction queue is of 4 byte, right? And in 8086 it is 6 byte, right? So there will be 6 bytes which can be queued in this instruction, right? Okay. Okay, then we need to understand the segment registers and IP registers a concept. We will be explaining them in coming tutorials in very depth, but I can just give you a roughly idea. 8086 and any 8088 both are 16-bit processors, right? So they can actually work on 16-bit information, right? So every internal register is present inside the architecture is basically of 16 bits, right? So CS, which is code segment register, we will see those that register in detail. Data segment register, stake segment register, extra segment register, or instruction pointer IP, right? These all are how many bits? 16 bits, right? Because 16 bits can be stored, right? 16-bit can be processed by a microprocessor, right? But you know that this 16-bit registers uh, are actually generating a 20-bit address, right? You can see that. I hope you can see this particular thing. It says that the address which is generated by bus interface unit is around of 20-bit. So how come we are using 16-bit registers, right? CS, DS, SS, ES, or IP. All of them are what? All of them are 16-bit registers, but they are generating address of what? 20-bit. So how they are generating? Because there is a summation or summer included. This thing is basically what? Summer. This is what? Summer, right? I hope you can see that address generation, right? So this is a summer. which uses two inputs, two 16-bit inputs, because both of inputs are coming from 16-bit register, right? Those two 16-bit values are coming, and 20-bit value is generated, which is used as address, right? Address to address the external memory, right? So this is somehow connected to external word, right? Let me use a bit. Okay, so this is connected to external memory, right? And this is a address generation procedure, which we will discuss in coming tutorials, in which we learn how two 16 bits values are added to come to generate a 20-bit address, right? Okay, we generated an address, okay, and then that address was basically connected to uh, certain program memory, right? And we fetched an information. Information came, right? That information could be what? Information could be instruction, right? So that will, first of all, it will go to here in instruction queue, because this is the place where it will be generated, right? This is a place where it will be first of all stored, and we will store those information uh, and process it on their turn, right? So first of all, one byte, second byte, third byte, fourth byte, fifth byte, sixth byte. If six of these bytes are full, will will be able to fetch another information, because all the instruction is full. We do not have any other capacity to store further instruction. So what is going to happen? Bus interface unit cannot fetch any further information, right? So but execution unit will take them one by one and process them. Right now, execution unit, let's suppose it is still progressing and it is still executing the instruction which was present inside execution unit, and our instruction queue is full. So what is going to happen? Bus interface unit cannot fetch further information, right? So it will stop working and it will wait for unless this instruction queue has a byte of significant place to store, right? You know that it is a 16-bit processor, so at a time 2 bytes will be fetching. So it will this bus interface unit will wait for instruction queue to be empty of at least 16 bits. That means 2 bytes should be empty, so that it will start again fetching, right? So that is why bus interface unit will wait unless this instruction queue has vacancy of at least 16 bits, right? Or 2 bytes. And those waiting time, right? When bus interface unit is doing nothing, he's still waiting for instruction queue to be empty, right? So that still time, or that waiting time, is known as idle state, right? What idle state? Let me write for you. Idle state, IDLE state. Idle state means processor is doing nothing. When I say processor, processor means what? Processor means bus interface unit, right? So when instruction queue is full and execution unit is working on some instruction, and this bus interface unit cannot fetch further information, so it won't do anything. So those period of time is known as idle state, for which bus interface unit won't be performing any task, right? So this is one processor, right? One parallel processing unit. The other parallel processing unit is very useful, and that is known as execution unit, right? So let's see what execution unit does. So execution unit, it has a variety of options available. First of all, and very important thing which is present in execution unit is ALU. I hope you can see that this red color summer, which is arithmetic and logical unit. So any type of arithmetic and logical operation like and, or, plus, minus, divide, multiply, all will be happening in this execution, sorry, in arithmetic and logic unit, right? So there will be certain arithmetic and logical operations that will be performed in ALU section, right? Which is present in our execution unit, because execution unit is responsible for execution, right? Furthermore, it has a instruction decoder, right? So this internal control system, it has an instruction decoder. Whenever instruction come inside this execution unit, first of all it is decoded. That means microprocessor will understand what needs to be done, right? So that is performed by this internal control system, which will actually decode it. So you can say there is one more decoder which is available in this internal control system, right? Okay, and then there are some temporary storage places during execution. Processor might need to store them somewhere inside inside a processor, so that they can actually fetch it, right? Okay, then there are some data registers available. Let me highlight it for you. Those data registers are these four registers. As I told you, there are every register present inside 86 or 88 is 16 bits. So they are generally name is AX, BX, CX, DX. So AX is also 16 bit, BX is also 16 bit, CX is also 16 bit, DX is also 16 bit. But since 16 bit can be divided into two different bytes. So one is lower byte, right? This is lower byte section, and this is the higher byte section, right? So every data register is further divided into two portions, which can be named as, for example, AX, it can be named as AH for A higher, AL for A lower. BX can be divided into two parts, BH for B higher, and BL for B lower, right? So that's how these data register can be used as 8-bit registers as well. So they are, if they are 8 bits, so there will be how many register? 8 registers. But if you consider them 16 bit, so there are only 4 registers. Okay. And then we come back to another important registers, which is basically stake pointers. Okay, pointer registers or index register, which actually involve stake pointer, base pointer, destination index, source index. So these are very well known and very important registers, and we will see them in detail in coming lectures, right? But you need to know that these are also present in execution unit, and they will be helping a lot execution unit to execute the overall instruction, right? Okay, then there is one more important thing which is called flag register. I hope in your computer organization courses or in microcontroller courses you have learned status register. So status register and flag register is same, right? There are multiple conditions or conditional flags which actually let you know whether what is the condition of microcontroller after last logical and arithmetic operation. For example, there could be zero flag, there can be carry flag, there can be auxiliary carry flag, and so on, right? Like digital carry, right? So there will be number of flags available, which will be serving as conditional flags. On the basis of conditional flags, we can actually take branch instructions in microprocessor, right? So this is the simplest layout of execution unit, right? Okay, here I want to mention one more important thing. So now you know the complete architecture or their simplest explanation. We will be considering them in detail in coming tutorials, but I hope you have understand the basic idea. But one thing is still remaining, which is called the Q. I told you that Q is 6 byte, but it works on the principle of what? Principle of FIFO, right? Let me write it: FIFO or FIFO, right? Whatever you call it. That is basically what? First in, first out. That means the byte which will be fetched very first time, it will be served first time. So first byte, okay, let's say I'm bringing the very first byte, so it will be stored here. Then second byte it will be stored here, the third byte it will be stored here, the fourth byte, fifth byte, sixth byte. So very first byte which came very first, it will be coming out of this queue and going inside this execution unit very first time. So that is called first in, first out approach. That means the byte which will come first, it will be serving in this manner, right? So that is called FIFO approach or FIFO approach, whatever you call it, first in, first out approach, which is followed by instruction queue. So this is the simplest or um simplified explanation of internal architecture. We will be observing these different blocks in detail in coming tutorials in detail, right? So if you have any question regarding this simplified architecture, you can post them in comment section. And I would say thank you so much for listening.